Your live question, we have a quadratic. We're given the equation of it just here. And it's basically modeling like a doorway of a room. So the y value is the height of the door, and then the x value, it's the width of the door. So the first part asks us to find the equation. So as soon as we see equation, we know it should be something with an equal sign. And it's the equation of the axis of symmetry. That means where is the line of symmetry, which we know is straight down the middle of a quadratic. And so we're looking for the minimum or the maximum point so that we can find what is the equation of that line. So we're going to go to our GDC, to the y equals, and I've written in here the equation of the parabola or the quadratic, and we're going to graph it. So at the moment we can't easily see what's going on, so I'm just going to change my window. I don't really need the negative values there. I tend to keep -1 just because you can then see the axis, and clearly the y values are just too big. So we could change this to -20, for example, and 20. Let's try that for now. In fact, we don't really need the negative part of this, so we could just change that to -2. And we can now see much clearer what's happening. If we wanted to, we could again change the y value. I could just go as far as 10, and that's going to make it even clearer to see. So we're trying to find the maximum point. We do second function trace, and this time it's a maximum. We click somewhere to the left, we click somewhere to the right, and then we have our value in the middle. So we can see there that the maximum coordinate is 1.399999, quite a few, and the y value is 3.136. And therefore, if I'm looking at it to 3 significant figures, then my axis of symmetry is an x equals. Okay, any line that's vertical is x equals, and it's x is equal to, and then to 3 significant figures, it's 1.40. Okay, and you do need that 0 there to show that it's 3 significant figures. It's 2 marks, so if you've got this, if you've got your maximum point but you haven't got any working shown, if you've got your maximum point but you haven't got your answer as a equation, then you would still pick up 1 mark. And if you've got your answer here, then that's 1 mark as well. Again, make sure it's to 3 significant figures. So the next part of the question says that to prepare for the event, we need a big square-based crate to move in, and it needs to remain upright whilst we move it through the door. So we can't change the angle of it. So we can see that the crate, if we just drew that on, looks something like this, for example. We're trying to work out, will it fit through the archway, or is it going to be like too tall and then have these corners that create a problem? So to work this out, you're told that it's 1.6 meters wide. So 1.6 meters, if we now know that the center point here is 1.4, then 1.6 wide means that we have an additional 0.8 on both sides of my central point or center of axis. So that's going to take me to 2.2 and 0.6. Okay, so if I can find out what height the graph has at 0.6 and 2.2, if it's more than 2, then that's okay, the box fits underneath. But if it's less than 2, then the box is going to go higher. So that tells me whether the box is going to fit or not. So I'm going to go back to my graph, and I'm going to do second function trace and then find a value. And I want to find what happens when x is 0.6. Okay, and we can see there that it's 2.112. Okay, so 2.112. So this point here is 2.112. And we can do the same again for the 2.2. However, we also know that it's a quadratic and that it should be symmetrical, and therefore 2.2 should be exactly the same answer, which we can see that it is. So that tells us that if we write it in terms of our function notation, the y value, or f of 0.6, so when I sub in x is 0.6, the y value is 2.112, and that is the same as when I sub in 2.2. And therefore, since that is bigger than 2, and the box is a height of 2, therefore it will fit in. Okay, so I can see here if I go to my diagram, if I just tidy this up a little bit, so we have the 1.4 in the middle. We know that the box goes from 0.6 to 2.2. So this is my crate. And I now know that my crate is 2 meters high, but at 0.6, the graph is actually 2.112 high. So therefore it will fit in, it goes underneath. Okay. So we can see there that therefore it will fit, and you can justify that at the end. Yes, the crate will fit, the box will fit, whatever you want to call it. And then you can explain why, and either you've got this bit of reasoning here, or you can explain it in words, explaining that the box is only 2 meters high, but the graph is actually 2.112. That was one way to do it. You also could have found out where is the graph 2 meters high. So you could have drawn on 2, found those coordinates, and shown ideally that they were outside of 2.2 and 0.6, and therefore it would have worked. So you could have worked backwards as well. You can't just pick any random point. Okay, it has to be something to do with the 2, the 2.112, or the 0.6 and 2.2.